on Tresca criteria. And we will start a new criteria, which is known as a different, not new, a different criteria, which is what we call it as von Mises criteria. So we have to learn both of these criteria, okay? So to just quickly recap what we had on Wednesday, I'm going to cut and copy and paste where we left off. So on this problem, we have discovered the element that is the most critical, and we dealt with element I, okay? So element I is down there. So just to quickly reflect on the question, we have to determine the diameter. Okay, we have to determine the diameter. So what we sketch over here, we discover that element I, right? The element that's below here is the most critical loaded, as seen down here. So we've been through a process where we compare the stress state over here, right? Based on normal stress, okay, based on the normal stresses, and based on the shear stress, but shear stress happens to be constant, right? So we discover element I has the highest compressive stress. From here on, we have to sketch 3D mole circle. Why? Because 3D mole circle, there's three possibilities to calculate tau max. One is stress max over 2. Second one is stress mean over 2. The third one is stress max minus stress mean divided by 2. So where we finish off, we realize that over here, right, what we discovered that over here, this is our point Y. Okay, then we have our X and Z. So that's where we are doing now. I was rushing plotting 3D mole circle. So from here, we know that this is our X and Z plane. Then we plot another circle, right? This circle, hold on, undo. Then we plot another circle. Somehow this circle, I think I know why, okay? We have another circle over here. And that circle that we just sketched, that belongs to our YZ plane. The first one is our XZ plane. And then we have another circle. Okay, we have another circle over here. And the last circle, this is our XY plane. So this circle tells us that stress max, right? Well, after constructing this circle, this tells us that stress max is positive, stress mean is negative. In order to use number one, right, stress mean must be equal to what? 0. In order to use the second option, stress max must be equal to what? Equal to 0. So for this stage, we realize that we have to apply stress max minus stress mean divided by 2. Okay. And we have derived this before when this is the condition. All we need to do now, okay, so we know that from 3D mole circle, we have to use the maximum stress is equal to stress max minus by stress mean divided by 2. And we have derived this out before, right? We know that that the maximum shear with this will be equal to the absolute value of stress X minus by stress Z divided by 2 squared, and then plus the shear xz squared. Okay, we have to apply this. So what we don't know from here, we have not a clue what is our normal stress X. Okay, we know that stress Z is equal to 0, and we also have not a clue what is our shear xz. Okay. However, we don't know now. Does not mean we cannot find. We can calculate all these values. Okay. So now I'm going to quickly get the other information across for us, right? So we have this data. Okay, we have this data. Okay, we analyzed it before. We have this data. That we know that the structure, let me get the diagram across so it's easier for you to visualize. So we did this earlier. Okay. We know that our stress X is equal to minus 250 pounds, and we know it's under compression. We have a torsion, okay, and then we have a moment. And based on the moment, we know that it's going to go on compression. Okay, so now we are going to focus on element I. Okay, the element I is this element down here, element I. So we are going to calculate the normal stress of element I. And we know that this is equal to Px over A. And then we are going to have minus, if we were to draw our transformation, X, Y, and Z. We know that this will be equal to mz over izz multiplied by y. Okay, so we are going to let C be the radius of the shaft. Okay, let C be the radius of the shaft. From here, we know the area is equal to pi c squared. And then we are aware that izz will be equal to pi c to the power 4 divided by 4. Okay. And we are going to let y to be equal to c. Okay. So from here, we can calculate normal stress at point I is minus, so Px, you have minus 2500 divided by the cross-sectional area, which is equal to pi c squared. And we also know that this is minus, and the moment is equal to 18,000. Divided by pi c 4, the whole thing divided by 4. And then we have to multiply by c. Okay. Now we know that over here, both of them are negative, and the formula, because this is px over a, this is equal to mz over izz multiplied by y. We know that is because when we did our analysis, right? We did our analysis here. We are aware that the normal stress is in compression, and the moment is also going to induce a what? A compression. That's why we put the both minus over there. So from here, we just need to tidy things up a bit. So this will be equal to minus 2500 over pi c squared, and then minus by 7,000, 1800. So it's 72. And this will be equal to pi c cubed. And if we were to make them a common denominator, and the outcome of this is your equation 1. And we found our normal stress. Next, we are going to determine our shear xz for element I. This is equal to T top about the x-axis multiplied by the radius divided by J. Okay. And note that J, the second polar moment of area, is equal to twice the second moment of area. So that will be equal to pi C4 over 2. Okay. So from here, immediately, we can get our shear. The torque is 27. Then the radius is C. The J is pi C4 over 2. So this will be equal to 276 times 2, 55200 over pi C cubed. Okay. Leave the pi down there, or not, you have to start dealing with what you call decimal places. Okay. So now it's still pretty straightforward because they're still all what? Under the configuration of whole numbers. Okay. So from here, we know that tau max will be equal to square root, right? We have stress x minus by stress z divided by 2 squared, here xz squared. Okay, we have this, right? So we were given that tau max is equal to 50 times 10 to the power 3 psi. Okay, so this is what we were given. So we will have what? 50 times 10 to the power 3. And then we will have stress x minus 2500 C minus by 7200 O. And then we are going to divide by Z is equal to 0, right? So this is equal to 2 pi C cubed. and then you have a square. Then we have a shear